Good evening everyone. In this video we are going to discuss about professional plus integral controller. So here the PI controller produces output signal consisting of based on the two terms, that is the proportional to error signal and proportional to the integral error signal. So the PI controller U of t is proportional to E of t plus integral of E of t into dt, because of the proportional controller as well as it is combination of proportional plus integral controller. So the proportional controller is the u of t proportional to e of t. The integral controller is u of t proportional to the integral of e of t into dt. So if the proportional plus integral controller, it becomes u of t is proportional to combination of e of t plus integral of e of t into dt. So then u of t is equal to kp into e of t plus kp by ti into integral of e of t into dt. So here kp is the proportional gain and ti is the integral controller. Okay, so then taking the Laplace transform of equation 1 with the 0 initial conditions, then we can get u of s is equal to kp into e of s plus kp into ti e of s by s. So that the transfer function output by input, we can get it as a kp plus 1 plus kp into 1 plus 1 by ti of s. So taking kp as a constant, we can get as a 1 plus 1 by ti s. Okay, so the equation 2 can get in this manner. So here R of s is the input value, U of s is the output value, ES is the error signal, feedback signal it will be sending over here, and KP. So this is the professional controller and this is the integral controller. Okay, so if we are sending over here, it will becomes like this manner. Then it has to be transformed like this. So feedback signal R of s, U of s by E of s error signal, and kp into 1 plus 1 by ti of s. So this is called as transfer function. So with the help of this transfer function, it has to be produced over the control output in the proportional plus integral controller. Then comes into the characteristics of proportional plus integral control. The advantages of both P control and I control combined PI controller. The proportional action increases loop gain and makes the system less sensitive in the variation system in the parameters. The integral action reduces the steady state error over here and adjusted by varying integral time, and also the value of kp affects both the professional as well as integral parts of control action. And the inverse of integral time t is called reset rate. Okay, the inverse is called reset rate. It improves steady state accuracy, and also it filters the high frequency noise, and also it makes response to the more accelerated. Then comes into the proportional plus derivative controller. So like same like a professional plus integral controller, here also the output signal consisting of two terms, that is the proportional to error signal and proportional to the derivative to the error signal. So the PD controller, the professional derivative controller, also we can call it as PD controller. So E of t is proportional to E of t plus d by dt of E of t into E of t. So here what happens in the previous equation in the professional plus integral controller, U of t proportional to E of t plus d by dt integral of E of t we have seen. Now U of t is proportional to E of t into d by dt of E of t because of it is a derivative control. So that d by dt it comes over here. Then U of t is equal to kp into E of t plus kpd by dt into E of t. So here kp is the professional gain and td is the derivation time. So on taking the Laplace transform of this equation 1, we can transform this first equation into like this: U of s is equal to kp into E of s plus kp into TDS E of S. So it has to be transformed like this. Then transfer function, the output by input, so U of S by E of S is equal to Kp into 1 plus TDS. So this is the transfer function of professional plus derivative control. So with help of the equation 2 and 3, the transfer function drawn like this. So here, so the original one, R of S is the input value, or E of S is the error signal, Kp is the professional gain, TDS is the derivative controller. So and this will be the U of S is the output, so the controlled output value. Then feedback signal it sends over here. So this equation modified like this manner. Then only thing is input value, error signal, and output value. So U of S by E of S is equal to Kp into 1 plus TDS. So this is the transfer function of professional plus derivative controller. Professional plus derivative control. Now we are going to see about the characteristics of professional plus derivative controller. It improves the damping and reduces the overshoot, and the derivative control acts on rate of change of error and not the actual error signal. The derivative control action effectively only during the transient period, so it does not produce corrective measures at any constant error. The derivative control does not affect the steady state error, but directly anticipate the error and initiate the yearly corrective action, and tends to increase the stability of the system. While derivative control has an advantage of being anticipatory, it has the disadvantages that amplify noise signal and may cause saturation effect in the actuator. The derivative control action adjusted by varying derivative time. The change in the value of Kp affects both the professional and derivative parts control action. The derivative controller is also called as rate of control. Then we will see the last controller, that is the PID controller. The PID controller, it gives the output signal consisting of 3 terms. Before and all only the professional plus integral controller, so professional plus derivative controller. Now it is the professional plus integral plus derivative controller. So the output is based on the 3 terms, that is the proportional to the error signal and proportional to the integral error PID controller signal, and proportional to the derivative error signal. So that the PID controller U of t is proportional to E of t plus integral of E of t into dt plus d by dt of E of t. So all the terms you have to add over here, and U of t is equal to Kp is professional gain, E of Kp into E of t, and Kp by Ti. So here Ti is the integral gain, integral signal, and E of t, and Kp into Td into d by dt of Et. So Td is the derivative time. So on taking the Laplace transform of the equation 1, it will become U of S is equal to Kp into E of S plus Kp into Ti Es of S, Es by S plus Kp into Td S E of S. So now with the help of this equation you can find the transfer function. Transfer function is the output by input, so that is the U of S by E of S is equal to Kp into 1 plus 1 by TIS plus TDS. So this is the transfer function of PID controller. So that drawing it will become, so the Kp TIF TDS, it comes in the parallel. So like this manner it comes. So finally this drawing it will be turned like in this manner. So R of S E of S is equal to transfer function Kp into 1 plus 1 by TIS plus TDS into U of S, that is a controlled output signal. So already people know that this is the feedback signal. What are the feedback signal? It comes from the controlled output. It sends to the error detector. Error detector sends the error signal to the controller takes amplify as well as modify the signal and sends as a controlled output over here. That is the function. So the characteristics of PID controller is the combination of proportional control action, integral control action, derivative control action is called PID controller. The combination has the advantages of each three individual control actions. The proportional control stabilizes the gain but produces the steady state error. That the integral controller eliminates the steady state error. The derivative control reduces the rate of change of error. So these are all the characteristics this PID controller should have. So with that, the module 1 is to get over in the control engineering subject. Thank you.